Hello everybody. Today we're going to talk about how to put in tuning pegs. These are the Godot stealth pegs, which sadly are out of print. But anyway, that you can see they're very lightweight. This is 10.6 grams. Really amazing feat of engineering on the part of the Godot company. And what I like to do is to put them in so that they're below flush, and I can put a cover plate over the back of the tuning pegs to cover up the mechanicals. And the other thing I get out of it is by precisely machining this little pocket here, I get a huge amount of support for the input shaft of the peg, which otherwise is a little bit fragile because it's this little tiny piece of metal here, and actually there's a hole in the middle of the shaft with some adjusting screws inside, so it's even less material than it looks like. Anyway, that's the job. We're going to do is take this neck in a milling machine, and we're going to put 6 holes in it, make it look like this. We'll first get it, we'll have to make sure we get it in the right place, so we're gonna find it, so-called find it, with this center finder. So we play around with this until it seems like it's in the right place, and then we'll zero the digital readout and travel down to this other hole here. These 2 holes were drilled by a layout tool from the front side pattern, that is. And boy, we're so close here. So I'm going to move the neck a tiny bit. Well, that feels great. That's not enough to talk about. That's really great. So in millimeters, so it's 8 to not even 1,000th, and in millimeters it's 0.025. So again, not worth talking about. That's fine, close enough. Gonna make sure it's nice and tight. I've got these strap clamps with aluminum with a little rubber pad on the bottom. Let's make sure these are socked down so it doesn't move. I'll call this 0, 0. And next we're going to drill and ream. We're going to do 2 cutters in this. First, we're going to use this little spur bit. Now, this was a regular drill that was probably about this long, which I cut off and ground to a brad point or spur bit, which, if you look at Riff number 001, you can see how that works. And then this is just a regular straight chucking reamer, it's called, which is a tool that brings the hole to a very nice finish. It's not capable of taking very much off. You can see there's no center to this reamer, no cutters in the center. It's only capable of following a hole that's a little bit smaller in diameter than the reamer itself, and taking just a tiny little cleanup cut on the hole, which is what we're going to want, because we'll get a bearing surface that is really good. So most of these kind of pegs like this have a bushing that goes inside the front of the peg head. I'm sure you're all familiar with those. And I don't like them. They're kind of cheesy. They don't attach to the wood very well, so I don't like to use them. I'd rather just machine the wood perfectly and see if we can't get the support from the wood. Now I'm setting the depth, and there's a little piece of plywood underneath that will take the drill after it passes through the ebony surface of the headstock, and it also supports the headstock really, really well. So this is our bottom of the cut. We're going to set a stop. Oops. I'm going to set a stop so that we don't drill into our fixture. And now go back to position and drill some holes. So I'm going to run this at 2400 RPM. And then we're going to feed manually down to the stop. Now we're going to move over to these dimensions. And so on. So we'll catch up to you on the next maneuver. Okay, we've got our holes in, and now we're going to set the depth of this reamer. Make sure it goes all the way through the head. So stop. All right, now we're going to slow way down to 750 RPM. And we're going to use a power feed to get a really nice finish. So we're going to engage the gear train and feed. And what's going to happen is it'll stop automatically when it gets to the depth that we set. So that's convenient. Okay, so now have a look, and so we can see that the exit side of the hole is just perfect. So we have three things to thank for that. One is this killer little spur bit. Another is this sacrificial piece of material that supports the ebony as the drill exits. And then, of course, the reamer, which follows up and makes an unbelievably beautiful, shiny hole with no tear out whatsoever. And that's the drilling story. Here we are at the Scripta pantograph, and we're gonna use this machine to cut recesses, to let in the little tuning pegs, the Goto stealth pegs. Now, you can see that these slots for the shafts are round bottom, and there's recesses here, pockets that are square bottom. So we have to use two different cutters for each of these pockets. And so the reason for using this machine for this instead of a router jig is that there's a lot of control, and I want these to come out really, really precise. I want the tuning machine to fit in there beautifully, and in particular I want the tuning peg shafts to be supported as best as they can be. So a pantograph is a machine that's designed to either enlarge or reduce, and so it can't be a one-to-one arrangement. This machine is set up so that it can be variable between 1 1/3 and 10 times, either reduction or enlargement. And that happens to reduce. You put the follower pin over on this side of the machine and the spindle here. And then if you wanted to enlarge, you would simply unbolt these and switch them so that the follower pin would be here and the spindle would be here. And then, of course, these are special slides here that adjust the parallelogram relationships between the motion of the spindle and the motion of this pin. Now this machine was built probably in the 70s, I think, and it was just at the wrong time because the numerical control and computer numerical control machines were just getting popular, and people were starting to switch over to those machines. So this one was sort of at the apex of pantograph design, and it was never used. I bought it as new old stock for cheap. And it is really a magnificent tool. It's got all kinds of adjustments. This side has a rotary table. This table can move back and forth. Both tables have T-slots, although I have a workboard that's covering up this one. They both have knees like a milling machine, so that the tables can be precisely adjusted here. And although the machine was made in France, it's calibrated in inches for the American market. So here we are. And it's got a spindle with a belt drive. The belt snakes around a pulley here and goes to the motor in the back. And spins pretty fast. It's a nice running machine. Again, nobody ever used it, so it behaves as new. I have it set up for this job at 10-to-1 ratio. So this is a particle board form that I made that's 10 times the size of the little tuning peg. And the great thing about this kind of machine is that when you make this pattern and then reduce it 10 times with a cutter, you reduce your errors in the pattern by a factor of 10. So it's a little bit of a gift in terms of accuracy. You can make a pattern and then it becomes even more precise as it gets cut. First we're going to cut the bottom of this recess, which is going to be just like this except 10 times smaller. And then we're going to change cutters and cut the slot with a round bottom cutter for the input shaft of the tuner. Okay, so we're going to turn the machine on and raise this up. So now we've found the surface, and in here we'll set this up to 0. And set depth at 185 thousandths. So now this is at the right depth, and we'll start taking a cut here. So there's our cut, the flat bottom cut. Looks fine. Now we need to change the cutter. So this tool came with very little paperwork and no wrenches, so I had to make these wrenches to change tools. We're putting in a 5/32 ball mill, and the happy accident between the metric system and inches is that 5/32 is almost exactly the same as 4 millimeters, which is the size of the shaft. Now, for this straight cut, we're going to put this insert in here to run the stylus, and we're going to move this up so that things stay square. We need to find our Z depth again. I'm going to fire the machine up. So that one's finished. And I'll take it out and show you a little bit more about how this works. clamping the neck is a little fussy. Well, it's really important it doesn't move, of course. So for positioning, I created this aluminum plate. So there's a couple of pins in the end holes that locate the plate to the headstock where the tuning peg holes are. And this plate registers on this pin here, so that it centers the pocket with the hole. You can see that I've left this extra wide here, and that's so that I don't break out. In other words, if this were cut to final size, I'd have trouble with the cutter breaking material as it exited the side. So I'll saw this off after all these are cut. So now to put this on for the next one, we get it to drop on the pin. And then, I didn't show you, but there's a line scribed on the table. I think it's a 36-inch radius arc. And so is the edge of this aluminum tool. And now I'm just eyeballing it so that the tool is parallel to that arc. And what that means is that I'll get an array. The shafts will be perpendicular to the tangent of this 36-inch radius arc, anyway, because it pleases me. They could be parallel, but and it would have been easier, but I thought it was nicer to do it this way. They splay out, and it gives you a little bit more room to grab the tuning pegs. So here, got a little wedge, a couple of clamps. Now, one little bonus here is that since this was all set up to do this slot in the previous hole, now we can just use it. It's all set up to do this slot, so we just turn it on and run it, and then we can change the cutter. So that means we only have one cutter change per hole, roughly. This is a little bit less trouble. Really nice machine. Now, most people are saying right now, why is this fool guy doing it this way when he could just buy a little CNC machine like the rest of us do? And the answer is that I had this machine, I knew how to use it, and it kind of tickled me that I had a job for it, so here's why I do it this way. And this thing comes out, this pin goes down with the table. And then we're going to find this. Okay. Well, and so on until we're done. So that's how it works.